Today we're going to look at the mechanism of Friedel-Crafts alkylation of benzene. This will involve benzene with a alkane to produce isopropylbenzene with HCl. Alright, now don't worry, the mechanism is literally the same as any other mechanism from benzene. Just the first step is a little different. Okay, if you're clueless as to what to do in your first step, always remember that it will involve this reactant and the catalyst. That's your biggest hint. If the question gives you, that's it. Okay, for the first step is the formation of electrophile. Draw this halocane in a little bit of expanded form so it's easier for us to draw the arrow. So this lone pair will attack this aluminium. Why? Because aluminium have an empty orbital, so it can accommodate the lone electron pair. Alright, this attack will form a new sigma bond. Oop, missing Cl over there. Don't worry. This will form a new sigma bond between Cl and AlCl3. Like that. It might look weird, but trust the process, guys. Don't forget the charge. Since Cl have given its lone pair to aluminium, it will have a positive charge, while since aluminium have accepted the lone pair, it will be negatively charged. Like that. Alright, now moving on to the second step, it is the formation of rhenium ions, your favorite step. Alright, copy back your benzene and your new electrophile for the second step. It might be confusing because, well, you have 3 carbons right now. Alright, the way I see it, whatever happens, the double bond will attack the carbon that is attached to Cl. It will not attack Cl or aluminium. No, it will attack the carbon that is attached to chlorine then. So draw an arrow like so. Why would this attack even happen in the first place? Well, benzene is very electron rich due to its delocalized pi electron system, you see. So it is quite attracted to this electrophilic site, which is the structure over here. But since both of this structure is actually quite stable, it will take a lot of energy for this reaction to occur. So we need to write slow on top of the arrow, just as we do with the previous mechanisms. Alright, now draw your rhenium ions. Don't forget the resonance arrow, 3 benzenes, and a big camera bracket. Why would I draw this? Why would I draw the branch like this? Alright. You might not see it clearly from the expanded form, but if we draw it in its branched form, it will look something like this. The center carbon will look like this, and the 2 carbons over here attached to it will look like a Y like this. Alright, and also you can draw the hydrogen to make it clearer for you to understand, okay? Okay, so since the double bond from the benzene is broken and now replaced with this thing, this place will be empty and like a bond, you see? So it will have a positive charge place, right? Like this. Now we want to symbolize the ever-moving electron in the delocalized pi electron system, right? So draw an arrow of the double bond moving like so, and then the double bond will be replaced here, and then the double bond here will feel peer pressured by this one and want to move as well. So draw an arrow to indicate it moving. Oh, I almost forgot, the plus charge will be moved here. Why here? Well, this is the only one lacking any special bond, I think. And then just copy back the double bond from there This double bond here will be moved just next to it, and the plus charge will be like this. Don't forget about the Cl and the LCl that we have left behind. I forgot earlier, we should have had an arrow over here to indicate that the sigma bond between this carbon and the Cl have broken, since, well, this part has already been taken by the benzene, right? So this sigma bond will be replaced to be a lone pair, so the side product will look like this. For the third step, it is the deprotonation of uranium ion. Copy back the first structure from your uranium ion to make your life much easier, like so. Again, just like their previous counterpart, this compound wants to seek revenge. It has been stolen. Part of it has been stolen, so it wants to steal something back. This lone pair will try to take H atom over here, and this H atom will let go from the benzene and return the electron from the sigma bond back to the benzene like this. But since the chlorine is holding on to too much at one time, AlCl3 will notice and humbly retracts itself. It will remove itself from this compound and return the electron pair, will return electron from the sigma bond back to chlorine. So once the AlCl3 have been separated, it will become a side product, its own side product. And the bond will form between H and Cl, so it will produce HCl as another side product. What about the benzene? Now that the electron has been given back to the benzene, this will reform the double bond over there. So we can write it like so. So we have successfully produced isopropylbenzene along with the side product. So our mechanism of Friedel-Crafts alkylation of benzene is complete